Okay, I will continue with this section 2.5 on some more important questions, I think, than the basic question we had last time. I've already picked and choose some problems from our textbook to go over, but mainly our focus in this follow-up part are not to find the equation of the lines, equation of the plane, or where they intersect, but we focus on the following things. First one, how those figures, lines, planes, point in space interact. Okay, now of course the first one that we already know, I will not review here, is the case, the distance between 2 points. Now that's just distance formula. Okay, the second case that I will which I will go over first later on is the distance between a point and a line. Okay, the third case, the distance between a point and a plane. Now, when we say the distance, it is always the closest distance, which means when we say distance to a line, it will be the perpendicular distance, and the distance to a plane will be the perpendicular distance to that plane. Okay? Now, also later on, we have the case of how two lines interact. For example, if I have two parallel lines, if they are parallels, can we find the distance? Which actually, it's quite easy. All you need to do is actually to find a point on that. Just find a point on one line, which is parallel to the other one, and then use that point to find the distance. Okay, so you will see I will not cover this part here. Maybe I do, but I don't think so, because the idea is quite simple. It's basically being reduced to the second case here. Okay, now the fifth case, which I think is difficult, is the case where if two lines are not parallel but not intersecting. Of course, if two lines are intersecting, then the distance between them will be the closest distance, which is 0, right? The other question may come up with two intersecting lines, or what's the angle where they intersect. But that's basically finding the angle between two direction vectors. Okay, which is again too easy, which I will not cover. Okay, now the one I think I will focus on is this last question here, where if we have two parallel planes, which means they may be on two planes that are parallel, right? And those two lines are skewed. So let's say one line like that, and then another line like this. And how will we find the distance between these two lines, which is basically the distance between these two parallel planes? Okay, but when we say the distance within these two skewed lines are is the closest distance. Okay, it must be the closest distance. That's the distance between those two planes. Okay, those are the things that I will do in these videos here. Let's start with question number 70. Number 70, find the distance between this point, number 70, you have a point 013. And so this is the point, and this is the line. RT equals to 063 with direction vectors. I kind of like decompose that right away to -2, 1. So we have this line here, line L, and point P. We want to find the distance. Now from this line L here, we see that it has a parallel, line L is parallel to factor 2, -2, 1, right? Okay, what we will do is we will find a factor from a point on L to P. Okay, now the idea is I will form a parallelogram, right? And basically find the distance between P to this L here. Okay, which, if you think about it, is basically the height of the parallelogram. Okay, that's what we plan to do. So let's go back. Let's choose a point on that line, and from here we see that we have that point, 0.063, and this point P here is 0.13. So let's call this, if this is vector V here, let's call this vector W, which is 0, -50. Oh, wow, that's a nice number, 0, -50. Okay, so the distance that we're looking for must be the magnitude of the cross product V and W. The distance equals to the magnitude vector V cross vector W. That will give us the area of the parallelogram divided by the length of vector V. Okay, now the length of vector V is 3, right? Square root of 4 plus 1, that's 3. Now how about the cross product? So the cross product is 5, 0, -10. Then the magnitude, therefore, is, notice that I can factor 5 out, right? I can factor, this is 5 times 1, 0, -2, right? So the magnitude will be the 5 square root of 1 plus 4, that's 5 radical 5. Therefore, the distance between that point and that line will be the area of the parallelogram, 5 radical 5 over 3. Okay, next, find the distance between the point, number 72, between a point and a plane. If you happen to know the formula, go ahead, use the formula. Okay, but honestly, I don't remember the formula. I think I do remember the formula. Okay, so number 72, the direct distance equals to, replace the xyz in that equation by the coordinate -c minus 2 times 3 minus 4 times 5 minus 8. Notice that I replace -6, 3, 5, which is the coordinate not on that plane. Okay, and I modified the equation and call this something to be 0. Okay, so I subtract by 8 both sides, divided by the square root of, basically divided by the magnitude of the factor normal to that equation. But when we say the factor, it has to be the factor that you see here, which is 1 squared plus -2 squared plus -4 squared. Okay, that will give us what? Absolute of -12, -32, -40, divided by 16, 20, square root of 21. So that is 40 over square root of 21. That's the distance. Now, suppose I don't remember that formula, then what can I do? I can do this. Well, the factor normal to that plane is 1, -2, 4, -4, right? Okay, this coordinate is -6, 3, 5. Now construct find a factor on that plane. Find a coordinate on that plane. I think I will use 800. Okay. I set y and z to be 0, so I have that x equals to 8, right? Then I create a factor from that 800 to that 635. So that will give me that factor to be, call that factor v, that will be -1435. Okay, this is the normal factor here. Now, so using the second method, the second take for this number 72, the second method to do that, notice that the distance that we are talking about is basically the magnitude of the component of factor v unto factor n, right? That's the magnitude of that component, which is equal to phi dot n over magnitude of n. I wonder if you remember the formula. Now, what is phi dot n? Phi dot n will be -1435 dot 1, -2, -4 over the magnitude of n, which is 1 squared plus 4 squared plus 16. I'm sorry, 1 squared plus -2 squared. What am I doing? Plus -4 squared. Okay, now on the top, I will get -14 minus 6 minus 20 in absolute sign over square root of 21. That gives us -40, right? 40 over square root of 21. Same answer. Okay, of course, if you memorize the formula, that will be greater. That will be better. But if you don't, you still can recover the distance by, of course, showing that doing that component thing. Now, number 73, 74. Find the distance between two given parallel planes. If we have two planes that are parallel, how to find the distance? Okay, we actually have a formula in our book. I think number 75, if you look at that book. But suppose I don't have that formula. Okay, suppose this is the first plane, 6z equals to 4y minus 2x, and 9z equals to 1 minus 3x plus 6y. Okay, first rewrite them into the equation that is equals to constant. So in this case, I will write this as -2x plus 4y minus 6z equals to 0. And this guy here is 3x minus 6y plus 9z equals to 1. Okay, now, and then let's say I will use this plane here and find a point on the other plane, and I will find the distance. Okay, so instead of doing plane to plane, I choose a point on the first plane and find its distance to the second plane. Okay, so if I call this plane number 1 and this is plane number 2, notice that can you find a point in the first plane easily? I think origin is there. Okay, then the distance we are looking for will be basically distance from that point on plane 1 to this to plane 2. Okay, which is equal to, if you remember the formula that I use up here, right, which is equal to basically absolute root of 3 times 0 minus 6 times 0 plus 9 times 0 minus 1 over the square root of the, I factor the 3 out, so I will get 1 squared plus negative 2 squared plus 3 squared. Yeah, because the factor normal to this is 3, negative 6 and 9, or 3 times 1, 3 times negative 2, 3 times 3. Okay, which is equal to absolute of negative 1 over 3 times square root of 14. Okay, so that's square root of 14 over 42. That's the distance. Okay, now the formula in our textbook actually does the following. If I would like to spend some time, so the second take is like the first plane is negative 2x plus 4y minus 6z equals to 0. And the second plane is 3x minus 6y plus 9z equals to 0. I'm sorry, equals to 1. Now, what you need to do first is to express this to have exactly the same coefficient. Okay, because they are parallel, right? They are parallel, then the factors must be expressible using exactly the same coefficients. So let's say I divide by negative 2 here. And this one I'm divide by 3. So I end up with x minus 2y plus 3z equals to 0. X minus 2y plus 3z equals to 1/3. Okay, now then the distance will be the difference between the coefficients, which is 1/3, divided by square root of the 1 squared plus negative 2 squared plus 3 squared, which you will get 1 over 3 square root of 14, give us square root of 14 over 42. Okay, but we need to have this situation first, where the coefficients are exactly the same before we get the difference between the constants. Okay, now then the coefficients, the magnitude that we use there are from here. Okay. Now, do you need to memorize these formulas? I don't think so. It is more useful for you to memorize the formula, distance formula between a point to a plane and a point to a line. Okay, from a point to a line. Now let's go on. I think this is the last question. I hope so. Yeah, that's the last question I want to go over here. Find the distance between two skewed lines. So let's say line 1 is given by R1T. That's 1, 1, 1. I'm sorry, 110 plus T times 162. And line 2 is given by R2S 1, 5, negative 2 plus S times 2, 15, 6. Okay, now we already know that they are skewed. So we don't need to prove that anymore, right? Now, but going back to the knowledge that two skewed lines must be on two parallel planes. Okay, so this is one of the line. Let's say this is line 1. And let's say this is line 2. The distance we are looking for are this. Now, from those pictures, we have the following. We know that, let's say one of the point in line 1 is 1, 1, 0. And the direction factors is 1, 6, 2. Now, another point on a point in line 2 is 1, 5, negative 2, and it has a direction factor called it phi2, 2, 15, 6. Okay, now I will rearrange these factors in a way that I can get the following. Okay, take a look. I want to find a factor normal to both of the planes. Call this factor n. Okay, notice that factor n is normal to phi1, also normal to phi2. Okay, so I can make it like this. Let's make that factor n, the factor normal to both planes, to be the cross product of phi1 and phi2. Okay, that's I, j, k. You know what? I will do that computation later on. Okay, now then I can create a vector from between those 2 points. Let me use black color. Between those 2 points, this factor here. Okay, the factor between those 2 points. So let's call that factor w, right? Factor w is the factor between factor from 1, 5, negative 2 to 1, 1, 0, which will be 0, negative 4, 2. Is it okay so far? Now, what I want to say is the following. Notice that when you do the cross product of phi1 and phi2, that will be the normal vector, right? Okay, and the distance between these two the distance between these two lines is equal to the distance within these two planes, which is equals to the component of this black factor here onto the red factor. Okay, in other words, we need to find the height of the parallelogram that is formed by phi1, phi2, and w. I need to find the height of this parallelogram. Okay, but the height of parallelogram is equal to the distance equals to the height of I'm sorry, parallelopipe, I should say, parallelopipe, which is equals to the absolute of triple scalar product, okay, phi1 cross phi2 dot w. I use absolute sign here to avoid that to be negative, divided by the area of the base of the parallelopipe, which is the magnitude of phi1 cross phi2. Okay, so I still need to compute that phi1 cross phi2, So this is I, j, k. The phi1 is 162, and then the phi2 is 2, 15, 6, which will give us 36 minus 30, that's 6. 6 minus 4, that's 2, becomes negative 2 for the second component. 15 minus 12, that's 3. Okay, so the magnitude of phi1 cross phi2, which we call n, is square root of 36 plus 4 plus 9, that's 7. On the other hand, I need to do the triple scalar product, phi1 cross phi2 dot w. I already have the cross product, so I can just go ahead with 6, negative 2, 3 dot with that w, which is 0, negative 4, 2. That is 0 plus 8 plus 6, that's 14. Okay, so we get here absolute of 14, which is 14 divided by 7, that is 2. That's the distance. Okay then, that's for this follow-up.